Gunnar joined the military at an early age. Eventually, he was deployed to Afghanistan to help detect bombs. At first, Gunnar's behavior seemed normal, but soon he was experiencing incredible anxiety. He wasn't able to follow commands or complete his missions, and after nearly a year of retraining, he was sent home. He had some trouble integrating back into society. He was still anxious and hypervigilant. His family was concerned but patient. Pretty familiar story, right? Not unusual? What if I told you that Gunnar's a dog? In the past few years, there have been over 50 similar cases reported by the military where dogs show extreme responses to combat. In Gunnar's case, his military handler believed that he had canine post-traumatic stress disorder, or PTSD. So why is Gunnar's story important? Well, there are similarities and differences in how humans and other animals respond to stress, but what's really significant here is that we're not the only ones that can have these extreme responses to adversity. Other species can too. So while stories of shell-shocked dogs have spread through popular media, the possibility that other animals might be susceptible to pathologies like PTSD has become a topic of heated debate in science. Some scientists suggest that PTSD may be an extreme version of an anti-predator response. There are few things in an animal's world more salient than predation threats, and they may get only one chance to learn about these threats. Supporting this is the idea that many of the symptoms of PTSD overlap with normal anti-predator behaviors like increased anxiety, quick startle responses, and hypervigilance. The reality is that stress can change your brain. It can change cells in your brain and how these cells communicate with one another. In brain regions important for learning and memory, cells can shrink and become more vulnerable to future challenges. In brain regions important for modulating fear, cells can grow and become better connected. Over time, stress can have devastating effects on health and behavior, and many of us know this from personal experience. But what's new is the realization that animals can experience the effects of stress much more like ourselves than many believed possible. My colleagues and I at Penn State have found that even if stress occurs relatively early in life, animals still show increases in anxiety, changes in the way they make decisions, changes in the way they face future challenges, and differences in the very way that they perceive the environment around them. These changes are present for the majority of their lifespan. But animals do experience stress differently. And by understanding those differences between how species process stress, we can better understand how evolution shaped our own stress response. One important feature that we share with other animals in how we regulate stress is our body's ability to shut off the production of stress hormones that is integral in our ability to recover from challenges. When we're under chronic stress, this shut-off system can become faulty. We produce our own marinade of toxic hormones that can suppress immune function, can kill brain cells, impair cognition, and suppress fertility. The consequences can truly be life-changing. It's even suggested that this may contribute to aging. But in one of the cases of the most extreme stress in a natural system, we don't see a reduction in the ability to shut off stress hormones. Take a look at a classic example of predator-prey interactions on record since the 1800s. Lynx and snowshoe hare populations rise and fall together. At some points in the cycle, populations of over 80,000 hares are nearly wiped out by lynx predators. With the hares gone, so goes the food, and soon the lynx start to die out too. But before they go, they can kill up to 90% of the hares. But those hares that remain, those few, still don't show this reduction in the ability to turn off hormones that we see in humans. One feature of the stress response that we do see in other animals is that offspring born to mothers under high stress environments can show a very familiar set of symptoms: increased anxiety, quick startle responses, and hypervigilance. These animals are reacting to a high-stress environment without ever having seen the environment themselves. It's believed that when stress has effects like this, from a mother to her offspring, that stress hormones may be acting as mediators to prepare that next generation to face challenges. So the question becomes, why are humans and animals responding differently? Well, we don't know yet. But what we do know is that differences between species and how they process stress can help us to better understand our own stress response. The roots of our current pathologies evolved in natural systems, and we can study those natural systems to better understand how and why these extreme responses came about. Regardless of whether or not you believe that a dog can experience something as complicated as PTSD, there are cases in other species where individuals, like some of us, show these extreme responses to stress. And we can better understand those individuals and better understand ourselves. So what does this mean for us? Well, unfortunately, there's stigma associated with mental illnesses, including PTSD. But it's important to remember that PTSD is linked to a biological adaptive response that evolved for dealing with life-threatening situations. A shift in the mindset may help to overcome these negative stereotypes associated with mental illnesses. The reality is stress can change your brain. It's a scary thought, but here's the good news. You can fight back. You can change your brain too. There are a number of ways to combat the effects of stress. Here are two of the easiest. The first is exercise. Exercise can do great things for your brain that directly oppose changes from stress. Exercise can increase cell density and promote survival of cells in your brain in the very same regions targeted by stress. Exercise can also keep cells that control blood pressure from growing unchecked. Just 20 minutes of aerobic exercise 3 times a week can help change your brain enough to offset the effects of stress. A second way to alleviate the effects of stress is to simply see someone with expertise in this area. A skilled cognitive therapist can help you change your brain to strengthen the connections that suppress fear responses. You can limit the impact of stress in your life by simply controlling how you respond to it. As for Gunnar, we now know that by better understanding his extreme response to stress, we can better understand ourselves. And we can help those like Gunnar who have suffered from trauma to live beyond their experiences. You can mitigate the effects of stress by simply controlling how you respond, and you can limit the impact of stress on your mind and your body.